Here at the Labster Space Center, you will deduce Newton's law of universal gravitation and learn about orbits and the solar system. This simulation uses voiceovers. If you don't have audio, using the lab pad is an important way to get the most out of this simulation. Is this the first time you are playing a Labster simulation? Perfect. Then let's... A spacecraft with our crew on board is heading on a mission to the moon. Turn to your left and click on a lab coat to pick it up. Talk to Sir Isaac Newton.
Allow me to introduce myself. All objects with mass attract each other through gravitational force. When we weigh ourselves, we are measuring the...
How would your weight and mass change if you were standing on a planet that was twice the size of Earth? Option A. Your weight would stay the same, but your mass would decrease. That's right.
Your task is to find...
As always, which law connects the acceleration of an object to the force acting on it? Option A. Newton's fourth law of motion. Option B. Newton's first law of motion. Option C. Newton's third law of motion. Option D. Newton's second law of motion. Absolutely. Newton's second law of motion states that the acceleration of a body can be Let's measure the gravitational acceleration here. Go to the workbench. Before you start, let me give a very brief introduction on how to measure gravitational acceleration with a pendulum. We can deduce the formulas shown on the measurement screen to assemble the pendulum. Raise the lab pad to see additional instructions. Hang a mass on the thread. Measure the period of the pendulum. Raise the lab pad for more information. Count the number of oscillations and stop the pendulum. Count the number of oscillations and calculate the acceleration g. Well done. As you can see on the lower right of the screen, the gravitational... What do you think will happen to the gravitational acceleration value if we double the mass attached to the pendulum? Don't worry, this won't affect your final score. Let's test and find out. Attach a different mass to the pendulum. Measure the period of the swinging pendulum. Count the number of oscillations and stop the pendulum. Count the number of oscillations and calculate the... Interesting. The gravitational acceleration stays the same. To deduce Newton's law of gravitation, we have to investigate how gravitational acceleration is dependent on m and the distance between two masses, r. We have already measured the gravitational acceleration with a mass of m equals... Find the controller box and change the mass of the Earth. It is set to always start with the real mass of Earth. Use the pendulum to measure gravitational acceleration. Repeat the measurement with another value from the 4 available values for the mass of the Earth. Well, all right, so I will add the missing data to the screen. Have a look at the data points on the screen or click the View Image button. How are acceleration g and mass m related? Option A, exactly. the gravitational acceleration depends linearly on the mass m. Thus, according to Newton, so we've found that the gravitational acceleration is directly proportional to the mass of the Earth m. However, click on Newton's book.
Welcome to the thought experiment I performed when thinking about gravitation and the moon. To understand why the moon... As you can see, the cannonball travels along a curved... Nice shot! When we increase the velocity of the cannonball, it lands even further away from the mountain. Wow, that was far. You see, with the right velocity, the cannonball enters into orbit. The gravitational force from Earth acts on the cannonball, causing it to fall towards the Earth. But the cannonball's velocity is now high enough so that the Earth's surface curves away before it can land.
I hope this thought experiment helped you to understand the concept of orbiting. Which of the following statements is correct? Option A. The weight of the orbiting object is 0. Option B. An object orbiting the Earth is in constant free fall but never... Fantastic. Indeed, the moon is in free fall, but it moves so fast. In general, what is the name of a force that makes a body follow a curved path? Option A. Centripetal force. You got it. The force which is necessary to keep an object on a... As you are now an expert on orbiting, we can calculate the Turn to the measurement screen to your right and click on the orbiting objects to calculate g for different distances from Earth. Have a look at the data points on the screen, or click the View Image button and compare the gravitational acceleration values for an object on the surface of the Earth, a satellite, or the moon. What is your guess for the distance dependence of g? Option A. Gravitational acceleration. That's perfectly right. This is one example of knowing the dependence of gravitational acceleration on the mass and distance, we have almost arrived at Newton's famous... In order to get the correct calculation, we need to multiply it with the... Now we know the exact expression of Newton's law of universal gravitation. We can... What is the approximate gravitational force between Newton and an apple on his workbench? Click View Image to see a sketch of the gravitational forces between Newton and the Earth and Newton and the apple. Option A. Gravitational force is approximately 1 Newton. Option B. Gravitational force is approximately 10. Brilliant! A more accurate calculation yields F. G. As you can see, the attraction is tiny. Gravitation is a very weak force. That is the reason why gravitation is in general only significant. Proceed to the hollow table in Mission Control. This is a very simplified model of our solar system. We have talked about orbit. Use the buttons on the screen to speed up the animation and use the scroll bar to zoom in. Newton's law of universal gravitation provides a very good theory of gravitation. And speaking of Mercury, approximately how long is 1 year on the planet? Well observed. A year on Mercury is 87.9.
Dr. One, can you hear us? Sorry to interrupt, but we're having a problem with our flight plan. We're really off.
The mass of the Earth was changing, you say? Oops, that was us when deducing Newton. All right, let's help pilot Pinback. We just need to help them find the correct velocity the spacecraft... Help Mr. Pinback to orbit the moon. This velocity results in a... Which of the following curves is not a conic section and is therefore not a possible trajectory? Option A, circle. Option B, parabola. Option C, Exactly. A cycloid is not a conic section. Help Mr. Pinback to orbit the moon. You have transmitted a negative delta V value so that the spacecraft will slow down compared to... You did it. The mission is back on track and our spacecraft and crew have entered an orbit around the moon. Let me ask you one last question. Do you feel like you gained relevant knowledge during this simulation?